Okay, so in the last video we discussed our custom stretchy IK setup for the leg, where we give the animator a manual control over both the upper and lower leg stretchiness, along with the ability to lock and unlock the stretchiness of the bones in the leg. In this video, let's jump over into Houdini and actually get that setup implemented. So I'm going to jump into Houdini. And the first thing I want to do is apply our stretchy IK tool to the bones in our leg. So I'm going to jump over to the character rigging tab and grab our stretchy IK tool that we set up on our shelf. I'm going to activate that. For our start bone, we want our upper leg, enter to accept, and our end bone, the lower leg, enter to accept. And that's going to set up stretchy IK on the bones in our leg. We have an IK handle. If we grab that, we can see that our bones are indeed bending in the correct way for our knee. And if we were to pull that beyond the reach of our leg, you can see that our bones are indeed being caused to stretch. Fantastic. So let's go ahead and reorganize the network a little bit, rename some of the nodes that were created for us. The first thing I want to do is rename the IK handle from IK handle to L_leg IK handle. I also want to grab the leg stretch start and move that up towards the hip, just so that the network's a little bit more organized. We can also jump down inside the chop network, and we've got an IK solver. I want to rename this to L_leg kinematics. Now, as discussed in Technical Rigging 3, where we looked in depth at inverse kinematics, I do want to go ahead and straighten the solution. And if we do that, I am going to pin this parameter pane. If we do that, we can see that our leg maybe isn't quite as accurate in terms of tracking as I'd like. It's probably a little bit hard to see with the encoding in place, so I'm actually going to boost the tracking threshold slightly to 0.00001, and that will give us nice and accurate tracking on the straighten solution for our IK. So with that in place, we can go ahead and unpin our parameters pane, and let's now set up our manual stretchiness, the ability for an animator to come in and say that they want to stretch our upper leg manually or our lower leg manually. To do that, I'm going to add some parameters to both the upper and lower leg. Let's start with the upper leg. I'm going to right click on the upper leg bone and come up to edit parameter interface. And from the edit parameter interface, I want to go ahead and inside the stretchy IK folder, I want to create two new float parameters. The first is going to be IK stretch. That is the manual stretch for this particular bone, for the upper leg. The second is going to act as a helper, if you will. It's just going to act to keep things a little bit more clear with our parameters, and it's going to be our IK stretched length. This is going to reference the length of our bone after it's been stretched by that IK stretch parameter. Basically, it's going to be IK stretch multiplied by our initial length. It's going to allow us to then reference that parameter inside our stretch ratio later on to make sure that we are indeed automatically generating the stretchiness based not on the original length of the bone chain, but on the new length of the bone chain as discussed in the previous video. So I'm going to go ahead and create two float parameters. The first is going to be IK stretch. We'll call this IK stretch. I do want to lock this with a minimum of 1. Again, we don't want to allow the animator to shrink that bone. We only want to allow the animator to stretch that bone. And the second is going to be IK stretched length. And again, we'll give that a label of the same. So IK stretched length. And since this is going to be controlled by an expression, I'm not going to worry about setting any ranges or locking the values of that parameter. Now, we need these parameters on our lower leg bone as well as our upper leg bone. Instead of creating them from scratch, again, what we can do is shift select both of these parameters, right click and come down to copy parameters. If we then accept the edit parameter interface window, right click on our lower leg now and come up to edit parameter interface. If we jump down inside our stretchy IK, right click on bow length and come down to paste parameters, it's going to paste both of those parameters in for us. So now we have the exact same parameters on both our upper leg and our lower leg. So we can go ahead and accept this. Let's jump over to our upper leg. And inside the stretchy IK folder, we can now see our IK stretch and our IK stretch length. I want to set the IK stretch length parameter. I'm going to push Alt E to bring up an expression editor. I want to set this to be the I length parameter. Now, for those of you who didn't follow along when we created the stretchy IK tool back in Technical Rigging 4, I believe, we did indeed create an bone length parameter, I length, which contains the initial values for that bone length. So that is going to reference this parameter. That's going to give us what is the length of our bone before we've done any stretching whatsoever. And we want to take that and we want to multiply it by our newly created IK stretch parameter. That's going to be our manual stretch. So you can see as we start increasing our manual stretch, we're going to multiply that by our original length, and that's going to give us the new stretch length for our bone. This is going to be very useful because later on we can reference this and know what is the length of our bone now as opposed to what was the length of our bone. So if we accept this, we can see currently with a IK stretch of 1, we're simply keeping our I bone length and having 3.32207. And as we start increasing our IK stretch length is going to increase as a multiple of IK stretch by I bone length. So we can set that back down to a value of 1. I can jump in, double click, Control C to copy that expression because we need the exact same expression over on our IK stretch length for the lower leg. So I'm going to Control V and paste that expression in there. You can see that we do indeed have a different initial bone length, but now as we start increasing IK stretch, we're getting a multiple of that bone length here as well. So now that we've got those in place, we can turn around and let's use our IK stretch inside our bone length, and that's going to allow us to stretch our bones, but we're not taking into account that result with our stretch ratio that's being calculated automatically for us based on our stretchy IK setup. So let's go ahead and actually take our bone length. I'm going to bring up, and let's first bring up the bone length for our upper leg. So let's grab our bone length, bring up the expression editor, and I want to multiply in with the existing bone length now our IK stretch parameter. We can go ahead and accept that. That means if we were to take a look, and our IK has, by the looks of things, just exploded. And let's take a look at why that has occurred. So indeed, it looks like what's happened is our upper leg has shrunk to nothing, and that's because I put a space in I length. If we delete that out, fantastic. So there we go. That is now working nicely. So if we were to jump over and start increasing our IK stretch, you can see we are indeed stretching out our upper leg. So let's repeat that for our lower leg. I'm going to jump over to our lower leg, bring up the expression editor for the lower leg's bone length, and multiply in the lower leg's IK stretch parameter. If we accept that, we can now go ahead, and if we jump over to his stretchy IK and start increasing that length, you can see that we are indeed stretching out our lower leg now. Now you will notice, as they are right here, we are very close to being at the end of the initial bone lengths reached. That means if we were to move our end effector, these bones based on our stretchy IK will indeed stretch. Now if I was to increase our IK stretch, we can see that really we have a lot more room to play with. If we were to move this end effector, we should be able to move it fairly low before we start stretching these bones based on a distance between the start and the end, because we've now given ourselves more room to play with. However, we're not taking into account this newly created distance. We are only taking into account the original bone length. That means if I grab our IK handle and I start moving it down, notice what's happening. Our bones aren't merely getting rotations changed, they are stretching instead of having their rotations manipulated. Look at that. You'd expect as you move the IK handle down, this bone would rotate down, this bone would rotate back out, the leg would straighten. Instead, all that's happening is the bones are getting stretched, and this is the incorrect behavior for what we want. So let's undo back to where that's back in its 0 location, and go ahead and jump over to our upper leg where we have a stretch ratio parameter. Again, this was set up by our stretchy IK for us. So I'm going to go ahead and bring up our stretch ratio in an expression editor. You can see what it's taking the distance between our stretch start, the node that was created by the tool, and our leg IK handle. Basically the distance between the very start of our bone chain and our target. it takes that distance and it divides it by the length of our original bone chain, and that gives us our stretch ratio, although we do make sure that we limit that with a minimum value of 1. Now, instead of taking the original bone length in that calculation, we now need to take into account that IK stretch parameter. That means we can come in here and we can use the IK stretched length as opposed to I length, and we can reference that inside our stretch ratio parameter. So instead of I length, we're going to reference the IK stretched length of both the lower leg and the upper leg. That means if we were to increase the IK stretch parameter, thus increasing the stretch, the manual stretch on our bones, we now have more room to play with. The length of our bone chain has increased, and as we saw in the stretchy IK video over in Technical Rigging 4, the length of our bone chain is used to divide whatever the distance we're trying to get, and that's going to give us that stretch ratio. So now we're saying the length of the bone chain isn't just the original length, it is actually the newly created length based on our manual stretches of the upper bone and the lower bone. So we can accept this, and now you'll see if I grab our IK handle, whereas before we merely stretched our bones, we now fold down and only stretch once we reach that maximum distance, the distance where we cannot reach by rotations anymore. We now need to reach by stretching our bones. So now we can see that our manual stretch is also working in conjunction with that automatic stretch, and if we jump to our upper leg and start increasing his IK stretch, we can see working in conjunction with the automatic stretch. Eventually automatic stretch reaches nothing and we start increasing out. We could come down to our lower leg and start boosting out his stretch as well. That means that anywhere between there we're going to get bending occurring. As soon as we hit the end point, we're now going to stretch. So I'm going to go ahead, zero out our foot, jump onto our lower leg and set a value of 1 for the IK stretch, jump onto our upper leg and also set a value of 1 for his IK stretch, putting us back into that default non-stretched pose. We do have one last thing to set up in this video, and that is the ability to lock our stretchiness on the leg. So I'm going to add that as a parameter to our upper leg. So let's right click on our upper leg and come up to edit parameter interface. I'm going to go ahead and I'm going to place this inside our stretchy IK folder as well. And let's create a float parameter. I'm going to name this parameter to lock, and this is going to be our leg stretchiness. Again, this needs to be locked with a minimum of 0 and a maximum of 1. Again, 0 meaning no stretchiness allowed, 1 meaning maximum stretchiness allowed. If we accept that, and let's just jump over back to our whiteboard for just a second. We saw that we have that parameter t is our lock, and we saw that with a parameter t we can do 1 minus t times our first value. Our first value, when t is equal to 0, we want to be a value of 1. We want 1 times our initial bone length, and we can add to that t times our second value being that stretch ratio multiplied by our IK stretch. That means we can come in and we can take our I length in our bone length expression, and we can take I length and multiply it by 1 minus that lock parameter we just created, added to that lock parameter times stretch ratio times IK stretch, and that will now give us the ability to blend between having no stretching affecting our initial length and just having our initial length, over to having the complete stretching based on IK stretch and the stretch ratio affecting the overall length of our bones. So let's jump back into Houdini. And on the upper leg, I'm going to jump over to the bone tab of the parameters and bring up the bone length in the expression editor. So currently we're taking our I length and we're multiplying that through by our stretch ratio and IK stretch to give us our stretched bone length. What I want to do is take I length and now multiply it by an expression that takes into account our lock parameter as we saw over on the whiteboard. So I'm going to create parentheses around our existing stretch ratio multiplied by IK stretch, and inside these parentheses we're going to create the entirety of that 1 minus lock added to lock times stretch ratio times IK stretch. So let's start out, and I'll put brackets here even though we don't need brackets. I'll put brackets just for clarity, because bracketing these together makes it obvious that we're doing 1 minus a parameter, makes it a little bit more obvious that we're indeed doing a linear interpolation type expression. So I'm going to take 1 minus, and the channel that we want is on this current bone, and we want the lock parameter. So 1 minus the lock parameter, and we're going to add to that, and because of the way the order of preference works, we're going to simply multiply our lock by stretch ratio by IK stretch. They'll be multiplied together first before we then add it onto this expression. So we're going to take our lock, multiply our lock by our stretch ratio and by our IK stretch. So now that we've got 1 minus lock times 1, so just 1 minus lock, added to lock times our stretch ratio by IK stretch. When lock is equal to 0, we'll get a value of 1 returned here, and that will be multiplied in by our initial length, giving us no stretching. When lock is a value of 1, we're going to get 0 here, but instead we're going to get 1 multiplied through by our stretch ratio and our IK stretch, giving us our stretch ratio and IK stretch returned, giving us that multiplied by our I length, which gives us our stretched bone length. So now that we have that in place, if we accept, we should be able to go ahead, jump over and increase our IK stretch and see that it has no effect because leg stretchiness is set to 0. If we now start increasing that over to 1 because we put an IK stretch on our upper leg, we should see that leg start to stretch out to that full stretch that we applied as we start bringing that back down. Something like so, and then we can blend between not stretched and fully stretched. Fantastic. We need to do the same on our lower leg, so let's jump over to the lower leg, bring up the lower leg's bone length, and let's go ahead and do the exact same expression. Of course, now we're referencing lock, and lock is now over on the upper leg, not on our cells, so the expression will be slightly different, but we're going to reference our L underscore upper leg / lock, multiply that, sorry, we're going to do 1 minus that, 1 minus our upper leg lock, and we're going to add that to our L underscore upper leg lock, multiplied by that stretch ratio, multiplied by IK stretch, the result of all of that multiplied by our I length. So with that in place, again, this is the exact same expression as we just saw on the upper leg, except for we're changing our references such that our lock and our stretch ratio are indeed referenced on the upper leg, not on the lower leg, not on our current node. So let's accept that, and let's test this out. So we should be able to jump over, increase IK stretch for the lower leg, see no change there until we jump in and start boosting our leg stretchiness up to a value of 1, giving us that full stretchiness on our leg, and now we can boost that down to a value of 0. Let's leave this as a value of 1. Let's jump in and increase our IK stretch on our upper leg as well. So we've got manual stretching going on both our upper and our lower leg. Let's jump in, grab our IK handle, move that down, and see that we are indeed getting the stretching that we need based on our IK. So now we've got both the manual and the automatic stretching taking place. If we were to jump over to our upper leg and decrease leg stretchiness, you can see that brings us back to having none of that stretching in place, no automatic stretching and no manual stretching, putting us back into that default pose there. Fantastic. So now that we've got that in place, we can go ahead and zero out our translation, and we can go ahead and one out our IK stretch for both upper leg and lower leg. And with that, that is going to conclude the setup of our custom stretchy IK. In the next video, we'll take a look at how we can set up the twist control that we discussed in the leg overview for our leg. This will conclude this video. Thanks a lot.